Hello, everyone, and welcome to this podcast from the Light Review. And I am absolutely overjoyed to my socks to have my old friend Deborah Burnett with me today, and with Scott Zimmerman. I've not spoken to Scott before, but we're going to be talking about a thing that is one of those, and you thought it was safe to go back in the water. Well, if you think you're comfortable with circadian lighting and all the rest of that, then hold on to your hats, because we're going to look at the next thing. And I'm going to, okay, who wants to give me just a little bit of background as to where we're going to go with this conversation about near infrared lighting? Deborah, do you want to do that?
Yeah. Basically, what I want to share with everyone is that what you know about pineal melatonin is just 5% of the story. And so what Scott and I have been working on, and the reason why we've got together, and Scott and I, we go back, 7, 8 years, I guess, when we started looking at UV and melatonin and just exchanging emails and, understanding that there's so much more that we're not getting from an industry perspective, because the researchers, they're bound by academic constraints, by publishing constraints, and dollars, or in this case, currency, whatever country you're from. And literally it's the currency, who's going to pay for their research. And so they're leaving a lot on the table. And so what Scott and I have been doing is picking up some of these pieces and putting them together and combining them with peer review research. And in Scott's case, actually doing the peer review research and seeing what is missing. And what we came up with was something that is really going to blow your socks off when it comes to melatonin. And we just recently had an article published in Design Lighting magazine that gives you just a little bit of information about something that's called extra-pineal melatonin. And that's what we're going to talk about today.
And that's why I'm talking to you, because I've read that article and I thought I now need somebody to hold my hand and actually take me through the dark woodland of this topic. Scott, how did we actually know that near infrared was an issue? Where did that come from?
Well, what we've been focused on is trying to understand. What I started out with is trying to figure out how light interacts with the body. My background is basically optics, and the deeper I dug into how sunlight, the body uses sunlight, was you find out that it's in the near infrared. There's this amazing series of mechanisms that the body has developed where the near infrared is collected and localized in your retina, in your skin, in your brain. All these things are happening and nobody knew anything about it because you can't see it. And it's very hard. It's somewhat hard to measure. Your standard lighting lab only goes out to about 700 nanometers, maybe goes out to 1100 nanometers. What we're talking about is the range. There's what they call this biological window that occurs between 650 nanometers clear out to 2000 nanometers. And in that window, photons from sun can go deep into the body, and what we're starting to understand is it affects us biologically. And it's kind of like when we talk about circadian, it's like we talk about spaghetti with no sauce. The near infrared component isn't used, isn't measured, isn't when you look at somebody's paper, you can't tell what happened in that thing. But when we're outside in sunlight, this near infrared component is the dominant part of the energy that our body absorbed.
Right.
And so the more I dug into the optics of it, the more it became apparent. And so what happened is I teamed up with Professor Ritter, and Professor Ritter is one of the world's experts in melatonin, and he has over 100,000 citations to his work. And, Russ was saying, Scott, this is something nobody's been looking at. We don't understand how this is working. And nothing that we're going to talk about says that circadian is wrong. It's just a very small part of what actually is going on in the body. And the dominant component for controlling a lot of your biological functions is actually the near infrared component that we, without any real research, got rid of when we started, because everybody needs to understand that sunlight is predominantly near infrared. And then as we worked our way through getting more and more modern, we decided, well, that part, the near infrared part, the UV part, we don't need those. We just need to take care of what goes on with our eye.
Yeah, when I did a little bit of work around sort of horticultural lighting and sort of chairing conferences and things like that, and I used to get really exercised, but with people saying you only need the red and you only need the blue.
Yeah,
and I'm thinking,
Right.
we've evolved on this planet for millions and millions of years, and we haven't found a use for the rest of it yet. This is
I like that.
rubbish, you know. And
yeah, no.
what you're saying there, I think maybe what are we saying? This has probably been a problem for the last 250 years, maybe, when we started to industrialize and we moved whole communities into the mills and into the factories and out from the fields.
Mhm.
Yeah, and
Um,
it's really only been the last little bit where it's been accelerating to a great extent, because it used to be, yeah, you maybe were working all day under a fluorescent light, but you went outside for a lunch break, or you went
Mhm.
home and read a book underneath an incandescent, which has lots of near infrared component, and you got to sleep. There wasn't a bunch of street lights sitting outside your door window
yeah.
shining in. But what's happened now is I call it, substitutional. We're not just exposing you to something by itself, we're taking away something. And so now we spend 93% of our time indoors. We were talking earlier about, healthcare. I mean, we're talking about some people in some of these elderly homes that get 5 minutes of sunlight a month.
Yes.
Mhm.
And so it's a major shift. And what we're now showing, what literally is happening now is that we're showing that is affecting hormones and having really
Mhm.
negative effects. We're basically putting people in an environment that is somewhat toxic in the way. And I use that carefully. I'm not trying to say everything's bad, all this other stuff. I'm simply saying that without the near infrared component and some level of UV, the body is in a weakened state, making it more susceptible to a number of different things. And what's happening is when people would think about talking about melatonin, we measure melatonin with somebody laying prone, no light, no
Mhm.
exercise, no food, and that's how we measure it. And that gets us this baseline that everybody, the classic thing, that cortisol's in the morning and melatonin in the night. That's your baseline. But the minute we walk outdoors, or we do any exercise, or we eat something, all those hormone levels are changing. Now, what we've done is we've taken away this major component of that was supposed to be there, because the function of the near infrared is basically to deal with the issues associated with being exposed to UV invisible. And so when you're outside, you're never exposed to UV invisible without an excess of near infrared. That's exactly the opposite of what we created indoors, because we
Mhm.
never get the same thing.
Yeah.
So
Yeah.
So basically, modern life then is sort of suboptimal, and
yes, I mean,
Mhm. Mhm.
it's not like you're going to die tomorrow. But the point is that without this other component, the body is actually being stressed. And there was this interesting study back in the 80s where they measured the relative ratios of melatonin to cortisol in people that had schizophrenia or clinical depression.
Mhm.
You know, if you take the baseline numbers that you're in the lit and you divide the melatonin by the cortisol, you do that number, we spend a considerable amount of our time at levels that would be called depressant, high levels of
okay,
depression. And so when you think about it, what is it we measure when we measure melatonin and cortisol? It's a bedridden condition. You're supposed to lay out flat. You're not supposed to get exposed to any sunlight. You're not supposed to eat
Mhm.
anything. And that's how we make the measurement. Well, you do those numbers, it really does say that, we are in a state of somewhat depression associated with, if that's all you do. Now, when you go outside, it's like a sandwich. The first layer is what under those conditions, sedentary conditions, we have a certain hormone level. Then the minute we start doing something, it starts adding. And the crazy thing is that nobody measured it before, because in order to see the effect, you have to actually do something. And so now that all these wearable biosensors are coming out, they're finding out that, hey, the minute I go outside and I start to exercise, cortisol goes up, melatonin goes up to levels much higher than what we do see when we're measuring circadian. So it's this new technology that's really starting to drive the information. And that was what our paper in biology that published last month was associated with, was to show that, hey, the minute you start doing exercise, 9 o'clock in the morning, you have a melatonin level that's up to 200 picograms per milliliter, much higher than you ever see at night. So where's it coming from?
And so the interesting thing about that is that in the laboratory for the circadian scientists, literally you are advised not to take what's called a sublingual, melatonin assay. In other words, underneath your tongue, because it's so much different than if you take a blood assay of melatonin. I remember going into Bud's lab back years and years ago, watching John Hannafin at the time, who was not even a PhD, draw some of the blood after having, participants in the lab. And so you have to understand that the sublingual draw of melatonin is not pineal, it's extra-pineal, and it's always going to be higher. Always going to be higher. And so that explains why, if you're doing, because I know a lot of design firms are saying, oh yeah, well, we're checking the circadian and we'll get a clearance to go ahead and just check some blood levels or check some sublingual levels. And they're measuring the wrong thing, in terms of if they're just doing quote unquote circadian lighting. So it's complex. And probably a lot of folks are wondering why I've got my skeleton here, Dr. Leakey. And so,
yes, we were.
Yeah, I know. And you were very kind. You didn't say, oh my God, Deborah, what's Dr. Leakey doing here? But we need to explain it from the very basics. And like Scott said about the sandwich, you have to understand what's the basics. And right now we understand, quote unquote, in the lighting industry, how the circadian system supposedly works, but we're missing a key component. So right now, if you just bear with me a little bit, I'm going to pull up a slide that's going to give you like the, quick overview of what's the difference between the pineal and the extra-pineal that Scott and I've been working on.
Thank you. Because the one thing that's been confusing me, and I think is going to confuse an awful lot of people, is we thought there was only one melatonin, and now you're telling us we've got two melatonins, and they seem to be doing opposite things. I mean, so that's...
It's not really opposite. They're supportive of each other. They just time frames.
We're all here.
Raise your hand, Scott.
Yeah, we're all awake. We're all walking around. So something's going right, but it's just so what's happening? What's happening? So under the hood, I suppose. Sorry, Scott. What do you?
Yeah,
waving your hands at me.
No, I was saying there's actually 4 melatonins, but that's okay.
Oh.
Yeah, see, we didn't even talk about that part.
Oh, yeah.
Right.
Yeah.
Okay.
Yeah, we didn't even talk about that part.
No, it's all the same. It's all the same melatonin. The issue is that there's different ways the body make. Bear in mind that melatonin was selected by the body for the pineal gland because it is the best antioxidant the body has. It's not only a great antioxidant by itself, all the metabolites that come below it are also antioxidants. So it is like the kingpin. There was a real reason the body chose to use melatonin to protect the brain during the night and so that it can continue to function and we can have our REM sleep and all this other stuff. But the point is that for that same reason, melatonin is generated in your gut, is generated in your skin, is generated in your brain. And all the cells that contain mitochondria have the capability, and this is what Russ has been spending so much of his time doing over the last 40 years, trying to explain to everybody, hey, melatonin's lots of places. It's not just the pineal gland.
Right. Okay. Deborah, we interrupted you so rudely. So you crack on with your
No,
first
no, this
line.
is the conversation that this is what we're doing. And this is what I so love about your podcasts and your video sessions with you and your audience, because it's like a normal conversation sitting around the table having a cup of coffee, and except that we bring in Dr. Leakey here. And
yes, he's
so,
a very quiet man, I noticed. So that's
yes, he's very Brit, you know. Okay, so right now I'm going to ask to pull up the first slide that we have. And so basically what we're doing is we're just looking at melatonin. And when you're reading some of these research papers, you're going to see that melatonin is abbreviated as MT, ME, MAL. It has 9 different opportunities to be, abbreviated, but it all means the same thing. It's melatonin. And like what Scott's saying, it's a critical by purpose. It's both a hormone and an antioxidant, depending upon where it is produced. Only 5% of the melatonin comes from the pineal gland. That's it. And the other 94% or so comes from inside the cell itself, in the mitochondria of the cell. And we get a little bit less, sometimes more, 1% from other different aspects, the microbiome, the food, the grass, all of this other things that is reflecting back in is going to be producing the extra-pineal melatonin that is involved and inside the mitochondria. So we also have to keep understanding when we're looking at extra-pineal melatonin that the mitochondria is everywhere throughout our body. We have about 37 trillion cells in our body. And in those cells, we have over 10,000 trillion mitochondria. And this is a critical factor because the mitochondria is the powerhouse of our entire body. And the mitochondria is going to work. And, the first law of dynamics, if you have work, it's going to produce waste. Well, you got to get rid of some of this waste. Bingo. Extra-pineal melatonin. And extra-pineal melatonin, Scott will explain in a little bit, is directly in line proportionally with the amount of NIR we receive. So, hormone and antioxidant. Melatonin wears 2 hats. It's vital for the sleep-wake system. It's a conveyor of light and dark signals. So many people have said that extra-pineal melatonin is the hormone of dark or light. Well, it's not a hormone, it's an antioxidant. The pineal melatonin is a hormone. And it's a regulation of reproduction, modulation of energy management, anti-inflammatory, and cancer activity. And this is going to be key when I talk about using Dr. Leakey here in a minute, because all of this, everything that's so complex in the biochemical, world and biochemistry, is all dependent upon where the sun is. Is the sun above or below the horizon line? And as lighting designers and architects, we've all looked at the, astronomical solar position. And the key thing is all of those degrees below the horizon line, they trigger very specific things within the body, different chemicals, different chemical responses, different hormonal releases are all geared to if the sun is above or below the horizon line. We started this conversation speaking off camera about nursing homes or care homes. And some of the factors that so many of my colleagues are failing to realize that the eye literally picks up the light and the solar position above and below the horizon line, even through closed eyelids. It's the cortisol awakening response. So in a care home, actually opening the blinds at 4 o'clock in the morning or the curtains will really help whoever is in that bedroom. But I'm going to give you a really quick soup to nuts explanation of the circadian system that we know, because this is how we understand it in the lighting community, but we're getting it wrong. We got a lot of it wrong. So everyone knows, the light comes in through the eye, but it's that 30-degree angle. It's not straight and it's not from down below. It's the inferior section. It comes in, goes to the suprachiasmatic nuclei, and then it goes to something called the paraventricular nuclei, where then the signal goes down to right about here, the superior superior ganglion nerve, right in through here, superior cervical ganglion nerve. Sorry, so many confusion sometimes. And then the signal goes all the way down to the adrenal glands, which are sitting right on top of the kidneys. The adrenal glands are going to be releasing the cortisol that Scott will talk about later. It also works with the serotonin. So much of the serotonin, more than 80% of it, is produced here in the enteric system, not in the brain that so many people think. So then when the sun starts going down and it gets to maybe nautical, it starts actually at civil twilight and then goes down to nautical, the signal from the PVN starts going, maybe it's time. And the signal comes further on down the column. Everything, serotonin, tryptophan, start rising up, and it will collect here near the superior ganglion nerve. And then when the sun goes down below the horizon line to at least 12 to 18 degrees, what happens, the signal is then released, goes back in a circuitous manner behind the cerebellum, which is where the other 15% of the serotonin resides. And then it goes to the pineal gland. The pineal gland, and this is the interesting part, the pineal gland feeds directly into the third ventricle of the brain. The brain has actually these cavities in them. So like when I've gone into the autopsy suites and looked in brains, this is really unique because the third ventricle looks like a house, a lopsided house. It actually has like a roof and a ceiling and a walls and a floor. And this is where the cerebral spinal fluid is actually produced. And the SCF is what goes up and down the spinal column. It is literally our life force. Also, the pineal melatonin is expressed into the bloodstream. That's the reason why you take the blood draws when you're doing the research on pineal melatonin at night. The interesting thing is that the CSF is also going to be controlling so many other factors with the body and the brain. And extra-pineal is very, very important because it is also working during the daylight hours. And the last remaining bit of the extra-pineal is picking up the slack when the pineal melatonin says, okay, I'm shutting off. So, and the reason why that is so critical, and we're going to pull up another slide here, and the reason why that is so critical, because between 2 and 4 o'clock in the morning is when cancer and tumor and diseases start cutting in. And that's when the body is the most vulnerable. And so here comes extra-pineal melatonin, and it's going to pick up the slack once the pineal melatonin, literally just says, okay, I'm finished. So on this other slide, it literally shows the sun coming through with the NIR, and it's going to be hitting the mitochondria. The mitochondria, as I said, 10,000 trillion of them, all throughout our body. And that's an average like 154-pound man. So what happens is when the NIR hits the skin, it's going to be coming in contact with the skin, the microbiome. It's going to go all the way down into the subacute layer, whereas some of the other wavelengths of light, they just stay on the top. Then what happens, it produces something called ATP. ATP is a very, specific energy driver. It literally is a force that is going to then generate something called adenosine. And adenosine is what we understand and need in order to be able to sleep. So the last part of this is where we look at what's called the homeostatic sleep propensity. So it looks like two roller coasters. Naomi Miller and I talked about this back in like 2008 or 9, and she said, Deborah, it looks just like a roller coaster. And it's like, yeah, you're right. Circadian rhythm comes one way, and the sleep pressure or the need to sleep goes the other way. And it's the adenosine that kicks in during the cortisol awakening response, around 4 o'clock in the morning through closed eyelids. And that triggers adenosine that's derived from the mitochondria, that's derived from the NIR in the environment to start picking up. And as soon as you go outside, the adenosine, it's like a self-fulfilling prophecy. It's like, oh, yeah, I use some, so I'm going to make more. And the more you exercise, the more adenosine it makes. And the more adenosine you makes, the better your body becomes because it's generating more antioxidants. And antioxidants is what the role of the extra-pineal melatonin is about. And the more adenosine you have around 10 o'clock at night, the faster you're going to fall asleep, because adenosine is designed to go hit the deck. It just drops almost like a rock. And that's where extra-pineal kicks in and stays in the background just to keep enough level of pineal melatonin and extra-pineal melatonin, more so than the pineal, in the circulatory system and available to fight off any type of cancer or tumor cells that will, they're very opportunistic, and they will take advantage of everything that's possible. And that's when they spread between 2 and 4 o'clock in the morning. And so that's what we need to understand about all of this. And Scott's got so much more to share, but I have to give you this rundown so you know that when we're talking about circadian, it's not just in your head. It's here in your kidneys. It's in your gut. It's everywhere. And the light we get at 30 degrees coming into the eye impacts everything, how we're going to sleep at night. And the light that we get on our skin, this is what, in our head, in our brain, this is what's going to protect us all night long and give us the energy we need to do what we have to do during the day.
It almost sounds as if our approach to circadian lighting is almost like a cargo cult. We've found one thing and we think that's what it is. And,
right.
and we've bowed down to that. And we've created our altars around healthful lighting. Around something which, as you say, is sort of 5% of the story.
Yeah.
I think that's a great way to say it.
Yeah. And people don't realize that it's the things that are around us that help us the most. And unfortunately, they don't cost anything. And so in our modern world, nobody's going to promote it because it's just like an orphan drug. We have a lot of orphan drugs out there, but nobody's going to make it because there's not enough people that have that disease to pay for the pharmaceutical development
we've got our National Health Service, which is actually a national sickness service. It doesn't promote health. It mends people when they're broken.
Yeah, exactly. Oh, that's my UPS driver. He's outside. So you just have to, bear with it. That beep, beep, beep that you hear, it's not Leaky saying that he needs to take a break. But Scott's got some 2 really wonderful slides that he's going to pull up in a minute. But I just want to share with you that this is such a complex topic, but it's so simple when you boil it down to that pineal melatonin is the hormone of darkness. Extra-pineal melatonin is the antioxidant, the protector, the soldier that comes in there and picks up the pieces. And it's the antioxidant or the molecule of daylight. And the more daylight we get, natural daylight, the better off we're going to be. And so, Scott, you've got some slides and, why don't you lead us into that?
Okay. So the next slide, actually, this is, I think Jim and you measured the moonlight spectrum, right, Deborah?
Yeah, we did that.
Yeah,
we did.
Yeah. Yeah. And it's kind of like, well, the measurement issue is important to talk about just briefly, because as I said before, most of the lighting or all the lighting labs only measure visible spectrum and maybe a little bit into what we call the near infrared. But the reality is the near infrared is the primary or the predominant amount of our photons that we are actually exposed to, or our body absorbs. It's just we don't know it because we can't see it. And because most of the lighting labs only measure out to 700 nanometers, they don't see it. And so if you look at the graph up there that Deborah and Jim did, they went through quite a bit of machinations to actually get what you see there. But if you could take that red area and extend it clear over to the other side of the page, that's how much spectrum is still going on in sunlight. And it's not even more than that, is that people don't realize, they think about light as just being something that hits the surface of your skin. In reality, a lot of it penetrates very deep into your skin, and you can see that quite easily with your cell phone. All you have to do is go in a dark room, turn the flashlight on, and put your thumb over the flashlight, and you'll see this kind of orange glow that starts to volume. And optically, this is what really got me started in this area.
Okay, I got to stop you a minute. I got to stop you a minute. The slide, that's actually moonlight. So that's not sunlight up there. That's moonlight. That's what we were talking about. Yeah. So we measured moonlight, and the image on the left-hand side, that's moonlight at 4125. And on the right-hand side is an equivalent LED at 4125. So so there's so much, even in the darkness, there is NIR coming out.
And you have to understand that the body, it's like a lot of engineering things, trying to do everything with absolutes is really difficult. But looking at things from the standpoint of ratios or slopes is much different. So what, as I said, and it's a true statement, the one constant that the body knows is, or has had for millions of years, is that there is always an excess of near infrared relative to UV and visible. And that body has therefore, and the fact that the near infrared can penetrate so deep, and it's not engaging the surface cells as much as it's generating the volume. So when Deborah talked about the trillions of mitochondria, you have this amazing capacity to generate a huge amount of antioxidants quickly, because you have this reservoir of mitochondria that, when, like I said, the published paper that we just had in biology, it shows a graph where it shows that, you go out and measure what happens when you start doing exercise. It's several times higher melatonin during the day at 9 o'clock in the morning than what we think of as when we talk about circadian. So it's like you've got this huge reservoir or capacity to deal with life. And so many of, as Deborah also said, it's basically for free, but we don't take advantage of it the way we should, because everybody knows, oh, it's good to exercise, it's good to go outside, it's good to go take a nap underneath a tree. Well, it's not only good, it's scientifically correct, because what we're finding is that the more near infrared exposure you have, the better the body is actually able to deal with everything from depression to to disease. So then on the right, you see one of my graphs that I published with Russ. But on the first upper left-hand corner is of the NIR sun optional, is what we typically talk about. People talk about the color temperature. And so sunlight, that's the spectrum if you're just directly measuring sunlight. But that's not what our body actually sees. The body is actually designed as a really amazing a collector, especially in the near infrared. So the next to the graph on the right is the reflectance of all our surroundings. So when you were walking outside, most of the visible light, our 80% of the visible light, is absorbed by the surroundings, like leaves and things like that. But in the near infrared, it's almost 80% to 90% reflective. So it's kind of like, if we saw in the near infrared, we'd be walking around inside this great big integrating sphere that is all bombarding the body with near infrared. And so what that does is that shifts the spectrum, that of the distribution of photons that are actually where our body is absorbing, into the near infrared even further. And then what you get is, you start, as I said, when I started doing these models, you start seeing these amazing optical effects from, we're optical nerds. So here's the point, is that the eye, the majority of photons that actually go into the eye and into the retina don't come through the pupil. They come through the sclera and through the eyelids, because the near infrared component, number one, it's the predominant thing that we're exposed to. Number two, there's an area relationship. So, and what is absolutely amazing about that eye is that it has a bigger optical window in the near infrared than it does in the visible. And so what you find is that what you would literally say is the eye is an amazing optical imaging system in the visible, but it is an even more amazing near infrared collector in the dielectrically filled collector of near infrared. And it's just amazing how it guarantees that there's always an even higher level of near infrared exposed on the retina. And it's this amazing way that the body maintains a certain proportion of the two, because what's happening is, as I said, is that the near infrared is always being collected and thrown onto the retina at 10 times the level that you would normally measure outside. So when people start talking about the upper left graph and say, oh, we got 3000 Kelvin, we got two, it really has very little to do with what we're talking about, because it's the near infrared component that nobody measures. And then at the bottom left, you can kind of see what the spectrum ends up being on the retina itself. So, and that's that slide.
You know, the interesting thing about the ocular orb, so many of the studies I know in architecture and interior design speak about the benefit of the gaze through windows, or the view. You know, you have the near, the midline, and then the distant view. And when you look at the orb, the way that the orb will rotate and move, when you're looking a long distance, your eye is almost perpendicular, you know, with the ground. And literally your eye is then exposing so much of the sclera, or the white part. And that's where the NIR is able to get in through the eyelid, through the lamarcane cells, the tear ducts. All of that is being flooded with NIR. And NIR is then contributing to the mitochondria in each of those cells to produce ATP and adenosine. So it's like, it's the more we're outside, the more we're going to be able to benefit. The pineal gland is very, you know, inextricably tied to reproductive, particularly the testes. And years ago, even actually at the first PLDC conference that I presented the keynote in like 2008, 2009, I gave a statistic that for males, particularly reproductive age males, if they were to walk outside barefoot in the morning, their testosterone levels, you know, shot up dramatically that night and the next morning. And it makes perfect sense, because every skin cell is a receptor for getting the NIR. The NIR is being reflected off of the grass and the trees, and it comes in. The NIR is outside. And this is what literally is helping us to develop, you know, a robust immune system. So much is needed from the mitochondrial production of ATP, adenosine, and it's all because of NIR. And so literally, the more you're outside, the better you are for your eyes, your body, your health, and your future children, I guess, if you want to call them that.
And you almost get it's almost like a common sense what's really interesting to me is that we have all the symptoms. Our modern society has all the symptoms of being sunlight deficient, because what you see is an explosion in the amount of people who are developing red light therapy, near infrared therapy. They're really trying to fill back in this gap that if they just walk outside, would benefit them. And that's what we're really finding because like there's a really nice paper that just came out, and they were showing that, you know, a very small amount of red near infrared on the eye has a huge effect on the protection or repairing cone death, or some of the parts of the, you know, your ability to see colors as you get older. And so if you go and if we pull up the next slide, it kind of gets in a little bit more detail, but it just illustrates that there is this huge window through the vitreous humor that allows near infrared to go and localize in the retina. And then bear in mind that the near infrared has been shown to do everything from improving tear duct performance, to reducing the interocular pressure, to removing waste. I mean, one of the big amazing things optically about near infrared is that, and they actually use this in to find your blood vessels, is that it tends, when near infrared goes into the skin, it starts to scatter because it's a, you know, fairly high scattering. and it starts to propagate, but it doesn't get absorbed. And people need to understand there's a difference between light being absorbed versus light being scattered. And what it does is it localizes the near infrared in your blood vessels, because it tends to cause an increase in, it causes the blood vessels to vasodilate. And that increases the amount of waste removal and all these other things. So, if you look at what we've done, is we took all that away. And when we decided that we only need visible light because that's the only thing we seek. And unfortunately, it's kind of set the body up for all these other issues. And like I say, I would say that, most of what's going on with the PBM, the low light level laser treatments in the visible area, in the red and the near infrared, are really just trying to make up for something we took away, unfortunately, because it's not just the LED lighting or the displays where we've gotten rid of near infrared. We've also put glass, the windows on our buildings block, reflect UV and reflect near infrared from coming in.
The low emissivity glass, particularly.
Yes, yes. And, there's a kind of interesting story that they down at Princeton, they had a professor and they put this amazing structure up. It had all these huge glass. It was basically a glass box. And, he was in his office, and one of the guys came in and said, "How come you had a heater here?" Because it feels so cold. It's because they took out, they're trying to save energy. I understand that, but they took out a component that made that represented the majority of the near infrared from coming into the building. And so there's this conflict that's going on. We're not just not getting outside. We're actually creating an environment that is actually counter to what is outside. And so it's almost substitutional and replacing something with good with something not so good. And then at the bottom, you can see from that in that graph is that on the right is what you get if you have LED lighting, as far as what the spectrum is on the retina. And on the left is what happens in nature, and clearly shows that nature went to a great deal of trouble. The body went to a great deal of trouble to take near infrared and localize it in our most important tissues. And we don't have the slide here, but the most amazing thing when I was doing and humbling thing when I was doing the optics is when you look at what happens in the brain, it is just absolutely amazing. I mean, literally, the near infrared, the visible portion is blocked. The near infrared penetrates through your skull into the cerebral spinal fluid that Deborah was talking about, and it acts just like a light guide, like we would use in lighting to distribute light out.
Wow.
And it literally takes the near infrared and moves it down into the fissures. And isn't it amazing that the gray matter is on the outside surface, you're surrounded by cerebral. So it's like we've got our own little light distribution system going on. And we know that it's starting to have, they're doing all kinds of work where they're trying to use near infrared to treat dementia and all that. Well, why didn't we have it there in the first place? So,
and the interesting thing is that the NIR actually penetrates bone. So it doesn't just go through skin, it goes down through the bone. And that is the critical.
And you start seeing some really interesting things, like the anterior side of the pituitary gland, as Deborah said, it has a big effect on testosterone and all that. Well, your air passage, if you look at optically, the light penetrates down through the air cavity, bounces around, and it just happens that the anterior, it's like a little pitot tube sitting down there. It's got its own little divot on the cavity of the skull, so that it kind of hangs down into that region, so it can actually get exposed to some of the near
actually
infrared.
it's that pineal gland, and it's called the pineal axis. And it, like the other ventricles, there's two laterals, a fourth ventricle, and the third ventricle is where the pineal gland sits, like right there in the middle of it, almost on top and in the middle of the skull. And it has this little like hook tail to it that literally is called the pineal axis, that goes directly into the cavity, into that third ventricle. So it's the only one like that. And it's really designed specifically to catch the light. And like fetuses, I know, Scott, you and I have spoken about, the research about fetal development. I first got onto it back in, I don't know, early 2000s from veterinary medicine, where literally NIR light going through the stomachs of female rats and mice literally is going to impact the fetuses. And now we're starting to do human research in that area. But the thing is that the light can penetrate so deeply into the skull and into all of the different aspects of the cavity of the brain. And this is the amazing part about NIR, that we're just totally oblivious to. And so hopefully with Scott's work and my work with Leaky and, trying to make common sense of this for the average lighting designer and architectural, community member and care home facility manager and everyone else out there, we need to get outside. We need to be able to take advantage of what we've been gifted with and how we literally are designed to function, how we're supposed to work.
Yes, I mean we're defeating our own evolutionary process by the sound of it. The three of us here, we're wearing tops, we're wearing trousers, and so there's some skin and there's some skin. This is the plea, isn't it? This is the plea from everyone now. What do we do? Do we all sort of take our clothes off and start running around the fields?
No, you don't need to.
Part. You don't need to. With NIR, it goes through your clothes.
Oh, it does? Oh, great. Okay.
Yeah, it goes through your clothes.
That's a bit
disappointing.
disappointing.
Anytime you feel warm in a space or sit next to a window, and it's like, okay, that's not, low emissivity glass. It's like real glass. Or you go outside and you feel the warmth on your back.
Yeah.
Or your dog hangs out in by the front door in the sun. They don't hang out in the shade. They hang out in the sun.
Yes,
they hang out in the sun.
Right.
So surely we're smarter than our dog. Well, I don't know, maybe not my Walter.
Well, hey. That depends on your dog. Sorry, Scott. Go on.
I was just going to say, we're probably one of the few people who are dumb enough to go out and actually measure clothes out to 3,000 nanometers. But they actually, there was a while back, there was a Roger Seaholt that I've done a number of different things with as well. He was pointing out that there was a time where they were going to put near infrared cameras on all the cell phones. Only problem is they got in a lot of trouble because they could actually see through people's clothes. And so they actually banned the use of it.
Well, that's proof positive for you then.
Yeah, but and what is amazing about the whole thing is that this component translates all the way. With children, they're smaller, so a higher percentage of their cells are actually exposed to near infrared when they're outside than adults. Mm-hmm. It's much more important because they're going through the growth phase. There's if you look at the Black population, we've measured, and thankfully we've been able to measure some of the different skin optical properties. And what you find is that someone with high levels of melanin needs about 3 times the amount of near infrared to generate the same amount of melatonin. Well, if you look at what went on during COVID, African Americans were running at died at a rate of about 435 per 100,000 up in the U.S. The group down in sub-Saharan Africa, they were dying at rates of 10 per 100,000. And there's just so much going on. The food supply, how chickens are raised. There's all this stuff that we are doing that is really pushing us more towards higher levels of cortisol, lower levels of melatonin in general. And by doing that, we're affecting things biologically that there was no intent. It was just, we didn't know any better.
For sure.
Yeah, and what Scott's talking about is the cortisol. We need cortisol. We need the generation of cortisol to be able to get up and to do things. But it's blunted there as like a specific ingredients, like a specific recipe. It's blunted by that extra-pineal melatonin in order to be able to keep it at a homeostatic or equal basis. so that we
Right.
don't get too much cortisol or too little. Too much cortisol produces so many, inopportune health conditions, as well as centerline obesity. So much of our centerline obesity is cortisol derived. We have different colors of fat. Brown fat is good, white fat, and then we have the orange yellow fat, and that's cortisol derived. And I saw that firsthand, through one of my first autopsies. It's like bright orange fat right here in the stomach area. And where are the adrenal glands and cortisol produced? Right back here. So, it doesn't have far to travel. I mean, fat's lazy. It's going to go right there on your stomach. So the NIR can help with that as well.
No, you mentioned chickens. Presumably, all life forms, and not plants, obviously, but I mean, a chicken's not a mammal. I was going to say all mammals, but a chicken's not a mammal. But anything that's got a heart and a digestive system and a brain is presumably working the same way. So if we've got intensive rearing of pigs and intensive rearing of chickens, we are damaging their prospects, and when we eat them, we're not doing ourselves any favors.
No, you might as well just take
cortisol.
Yeah. You're taking a cortisol shot every time you eat a chicken breast.
Yep.
Excellent.
And
okay.
And what's amazing is that it's so complicated from the standpoint of like the FDA bans the use of hormones and steroids in our meat processes. So instead, what has happened is that via inbreeding and genetic whatever modifications, we now have huge amounts of chickens that are barely able to walk, but are under a constant state of stress. And what happens in its chickens, when you're in high levels of stress, you generate high levels of cortisol. And so, and a number of other not so good things. So even though your package says it's hormone free, we've basically developed a set of birds that are a population of birds. There's 33 billion chickens out there.
Yeah.
And it's just amazing how pervasive the problem is getting to be. And what's the solution? Well, you don't put 100,000 birds in a cage under artificial lighting. You let them separate them out a little bit. And, one of the things that's probably going to drive this whole thing is the fact that, they're having such huge financial losses because one virus comes into the avian flu comes into, they have to wipe out the entire building of the flock.
On a very, like bring it down to human level understanding, in terms of like what's in it for me, that's how we all gauge things, like what's in it for me. Well, when you have a free range chicken, and I speak from experience because back 30, 40 years ago, when I raised chickens, in Tennessee, so I had to do something. So I raised chickens. So, I immediately noticed the difference in the taste of the eggs itself. When the chicks are allowed, and the chickens themselves, are allowed to go out and do what chickens do, which is scratch the ground and they cluck. The cluck is a very interesting signal. It's a vitality signal. If it was a songbird, it would be a mating that involves their testosterone levels the next morning. But in chickens, the scratching of the ground and the clucking of the noise literally feeds back into their health and vitality, so that the reproductive ability for the eggs, it's going to give the eggs that extra. I don't know what it is. I've been so far away from chickens all these years. I don't know the terminology, but they taste better.
Yeah. Deborah, you've been busy. Difference. Don't worry. You've been busy.
Yeah, but because there's no cortisol in them. The chickens were happy. Why did they have to, there was no reason, to be, have high levels of cortisol.
Right. Okay. Here I think is the crunch point. We know our industry. We know our industry well. So where's the snake oil coming from? When someone watches this conversation and goes, somebody go and find me some NIR LEDs and we'll slap them into our fittings and then everything will be fine. So where's the snake oil?
Okay, I'll tell you where the snake oil is. There's several papers out there, one of which I circulated about 4 years ago, that literally looked at artificial vis, UV, and NIR combined in one luminaire, and the results were devastating because the mix was not exactly the way the body has it. It was close, right, but it wasn't exactly there. It was disrupting the microbiota that live on the skin. It was disrupting so many other factors. I did a presentation at Light Fair in 2019 on the skin, and people were like, oh my God, that lives on me. I was like, yeah, but you want them to be there. You know, you want them because they're part of your innate immune system. The two immune systems we have, they're the most primary. They're the frontline immune system. And so when you have artificial, without really understanding the heat component, the ability of NIR to generate the real true NIR spectral power distribution that Scott's been showing, this is where you get into trouble. And so basically the best way, you know, is using a combination of old-fashioned, almost incandescent with LED and working that together. And Scott can really go into detail on that. Yeah, he's got a bulb to prove it. Yeah. You know, but it takes work.
Yeah, okay. Well, and Deborah's Deborah's 100% right. The problem is that there's not like one. If you talk to the PBM or the LLT people that are doing stuff, there's one magic wavelength that they particularly think.
Scott, define PBM so everybody knows.
Photobiomodulation, red light therapy, and the things like that. You know, they pick one particular wavelength, but the reality is the body, as I think John, you mentioned, the body takes advantage of everything it can. Mm-hmm. So if you go out into the near infrared, you'll see all these different absorption peaks. And all those are different things that the body is doing with that near infrared. Mm-hmm. And, you know, the point being is that the old incandescent was great. Nobody liked it because it generated tons of broadband near infrared. It's 100% efficient, basically, at generating near infrared. But it's terrible at generating visible light, you know. Yeah. And so everybody said, well, we can't do it. And in order for it to generate visible light, you had to drive the filament at such a high temperature or halogen or whatever that it had very low life. Well, what we do is we do a hybrid system where we use the LEDs to generate the visible portion of the spectrum, and we use short level filaments run at low voltage to generate the near infrared component.
Well, that's saved me breaking one of your lamps in half, isn't it? Thank you. I was wondering how you were doing that.
Well, I've published on it, and it's been filed on, so you can do whatever you want. I'm a little guy. I'm not going to tell Phillips to go jump in the lake. But anyway, the point is that it's easy to do. It's very easy to do. We have to get past the issue that, you know, the nice thing about doing it that way, when you run, you've all heard about the century bulb or the centennial bulb, right?
Basically,
explain it for those who are watching.
Yeah, it's anyway, a fire station in New York City that's been burned
for over 100 years.
Yeah,
and the point is that
or something. Yeah,
if you let the incandescent do what it does best, which is to generate near infrared, and you run it at a lower voltage, it actually outlives an LED. You know, and that's been proven with the century bulb and all that. Because the point is you're not driving the temperature of the filament up so high that it's near the melting point of tungsten. So what we do is we do a combination. We put it in a 919 bulb, and we basically combine the two together. The cute trick is that you can also have a huge savings for the from the standpoint of controls, because what we do is we use the filament bulb as exactly it's a current versus voltage characteristic is exactly opposite that of an LED. So when you put the two of them together, you actually linearize the whole thing, and it makes it so that you can simplify all the dimming. The system that we put down there at Princeton has a 10,000 to 1 dimming range, and what it does is to your point, John, it's not a color shifting. What it is that, well, it is color shifting, but what it does is that when you're running at the upper level of the voltage, it's mostly most of the light coming out of the bulb is still visible and near infrared. But then as you turn the voltage down, the LEDs eventually turn off and you go into an incandescent, and you can go all the way down to essentially nothing. And so you have this amazing way. It's by making the bulb a hybrid, it essentially simplifies all the control systems that people are trying to do. Because one of the things you'll notice is anybody who tries to do color tuning or tries to use red LEDs or near infrared LEDs, they all are changing in how they age. And so you'll get purple street lights and you'll get all these things going on. Using this approach, it's easy enough to where it's always the same thing, basically.
Can I ask? We're just on the cusp of having new energy standards published, and because we've got an idiot government, they just want a number, and we're saying to them that doesn't get us to where we need to go. There are other ways of doing it. No. We just want a number, and that number is going to be 120 lumens per watt from a light source. Now, I suspect that your lamp doesn't reach that figure.
Well,
because you've got a tungsten filament in it.
Yeah, and I'm trying to when it's on full brightness, it is. We chose based on the optics that we were looking at for different populations in the different population groups. We do at full brightness. We have a near infrared ratio to visible ratio of 3:1, and those are in optical watts. So using that situation, you're probably looking at somewhere around 80 to 90 lumens per watt. I was 5 years ago, I was sitting at the DOE as a panelist when they were going through this rule change back then.
And the DOE is our Department of Energy.
Yeah, the Department of Energy. And all the other groups were there to try and say, hey, we need to shut down all the incandescents. And I was sitting there saying, there is no photobiological similarity between that LED and an incandescent bulb. And your guys are going to create a real problem. They didn't listen then. I don't know if they'll listen now. But our intention is to just go ahead and sell our bulb. And you can call it a therapy unit. You can do whatever you want. But they're 100% wrong. It's kind of sad, to be quite honest, because they're going to make people sick is what they're going to do.
Do you think there's any mileage in the idea of just having an NIR fixture, whether it's a downlight or whether it's so no visible light comes out of it, so it's not a light fixture, but it's a generator of NIR which you can then promote on health grounds? Have we looked at that? People.
Okay, for me, I think it's a slam dunk. It's a red incandescent light bulb at night in your hallways, in your kitchen, and in your bedroom, and for care homes next to the bed. It's a red incandescent light bulb. Literally at night to help support the remaining circulating extra-pineal melatonin. And then, Scott, you were saying.
Well, I'm just saying that in our particular case, what we believe is that, you should have it not only during the night, but also during the day.
Oh, yeah.
I mean, people are sitting there staring at a screen that contains 0 near infrared and yet is stimulating high levels of cortisol, alertness, all these things. It's kind of like taking alertness to the point of being chronic is not good. And
the thing that Scott's going on right now and for the NIR during the day is like when you're looking at the blue screen, short wavelength light, and you're getting a headache and you're getting a pain, or you have glare. It's primarily from the concentration of short wavelength coming in. Well, that is producing cellular waste behind the retina, because the retina is working overtime, particularly the cones and the isomerization process. It produces waste, and that waste is called lifeucin. And lifeucin is like garbage And NIR, natural NIR, when you're outside, you're getting a lot brighter light outside. You're getting the full spectrum, but you have NIR to remove that light fusion from behind the retina. When you're looking at your computer screen, there's no NIR. You're just building up garbage back there. It's like New York City during a garbage man strike. All the bags are out in the street and they build up and build up and build up. And that's what causes the pain, the glare, the sensation, the headache, and all of that. So NIR during the day, maybe workstation NIRs, individual lamps over top of your computer.
Do we have any idea about sort of length of time of exposure? Because that's been one of the things on Circadian, hasn't it? That if you're going to do Circadian entrainment, you either blast it with a hell of a lot of light over a relatively short period, or you do a more sensible level of light over a longer period. But with NIR, it sounds as if we should have it all the time.
Which is not
sensible, of course.
Yeah, if you're outside, you are, because the moonlight, you get NIR from the moonlight.
But if you're in an office for 8 hours a day,
you're getting nothing.
You're getting nothing. But if we say to people, please, 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 go outside and walk in the street for an hour.
Yes.
So
but that's where the rub comes, and whether or not, will people do it on a consistent basis. I get asked all the time, is a sauna good? I say, yeah, sauna's good. But if you actually look at what happens from the standpoint of the melatonin, bear in mind that what happens, the body is constantly filtering out or taking melatonin and cortisol and all the hormones out of your plasma. And so they call it, what they call it, is a half-life. And essentially what's going on is that you take a melatonin pill, or say you go outside. Well, that's going to have an effect, and it's going to hang around. It's going to the effect is slowly going to degrade. And typical half-lives for melatonin are on the order of 8 to 20 minutes. So, and cortisol can be a little longer, but you got these, if you go and you just do something once for 10 minutes, 20 minutes, it's kind of my pet gripe with a lot of the photobiomodulation is that they're always trying to find a condition where you can get it all done in 20-minute office visit, And so we bump the power up, and then we say, oh, you got to be higher so that I can get it all. But you're really getting it in a 20-minute time frame. If instead, you'd be much better off, in my opinion, that you get a continuous exposure, because really that is what is the most amazing thing about when you think about it, the proportionality. I could care less whether you're sitting out on the beach, or you're under a shade tree, or at night. There is a proportionality that the body is expecting to see. That's what the environment that we're supposed to be in is. And that's the one constant. There's 8 orders of magnitude difference between the lux level at night versus being out in direct sunlight. The body is having to deal with that, and they deal with it by and these hormones are being shifted around and changing the baseline. We talk about a homeostatic baseline. That's true for a set of conditions, but then there's an entirely different baseline that's associated when you're outside or you're exercising. So the bottom line is that, if you're not getting it in the right proportion, it's a negative effect, in my opinion.
So. Right. And that's the reason why one of Scott's slides, showed that, looking at the astronomical solar position above the horizon line, the morning, getting the UVA and the NIR in the early morning hours, you get a robust charge of it. And the middle part of the day is designed primarily for, getting the UV, the ultraviolet, all of that information that needs to be absorbed by the body and the brain, because the brain is anticipatory. The brain works on an anticipatory pattern, and that's what it expects, just like Scott's explaining. it expects to be outside. It expects to have darkness at night, brightness during the day, and 3 different, gross levels of, morning to prepare, the middle of the day to survive, and then the remainder of the half of the day when the sun's starting to set, it's still above the horizon line, to repair, to get the last bit of information in there from the NIR to be able to impact the mitochondria for the ATP to the adenosine to get you ready to take the hit to dive down deep so you can fall asleep at night. And it's all designed, and the brain works on this anticipatory pattern. And we totally messed it up by living inside so much.
And there's a, if I could real quick, have you all heard about night milk?
Night milk? Okay. What's night milk?
Well, it turns out when you have a baby, the baby has basically no ability to generate melatonin or cortisol. And so what happens is that the mother, in the process of breastfeeding, is essentially teaching the baby to, synchronizing the baby to her circadian rhythms.
Well, actually, the melatonin is in the breast milk from the mammary gland. I never heard it called night milk before, but that's what happens when you don't naturally breastfeed, because all of our formulas don't contain melatonin, because the baby, when it's born, doesn't have a circadian system. It usually will kick in several months later, because the process of birth blunts the baby's circadian system while it was in the womb, and then birth, it literally is just free running. And that's the reason why babies, they just sleep and eat. And,
but we were talking, what I was trying,
they figure it out.
Yeah, well, what I was trying to say about it is that what happens is that the mother has her circadian, as Deborah said, the melatonin's in there, but cortisol is also so it's essentially synchronizing the baby to the mother. But what happens in a modern society is most women, or a lot of women, pump, but they don't keep track of the time. They write down the date usually, but they don't keep track of the time. So what happens is that you get you may be feeding the baby high cortisol, high melatonin, and then night milk at dairy farmers. I'm from a bunch of dairy farming. Night milk's pretty well understood because melatonin levels are much higher in cow's milk at night, so they call it night milk.
That's why I never heard of it. I never raised a cow. Okay.
Yeah. And so the point being, but then the farmer goes and dumps it into the same bin with what he did in the morning. So we lose a critical component. Now, what's going on? What it appears is that the mother is essentially teaching or programming or synchronizing the baby to a particular local time sequence. And if they don't do that, and if you look at formulas, they don't keep track of it. It's mostly cortisol. So what you have is you have this situation. Well, there's a number of studies out there now that are linking some of the ADHD issues to not having a strong synchronization, to women who don't breastfeed. And that's not to shame anybody one way or the other. It's just the biology of the whole thing. And you keep on finding all these different things that the body has gone to extreme lengths to, take advantage of what nature provides. And then we come in with what we're doing, and all of a sudden we're kind of wondering what's the problem. So I guess that answers, trying to answer your question about, the snake oil and all this other stuff. We need a lot more research in the area to understand what's going on, but it is absolutely clear that we are creating a set of hormonal issues. I have a friend that his son has ADHD, and to me is just amazingly tragic. I mean, they put him on Adderall, and at 7 years of age, he wanted to know how he could kill himself. This is stuff we got to start figuring out, and you can't just put a pill in. And the problem is that they eventually got him to where he was on a time release version that made it so it was a thing. And Deborah, knows this as well as anybody. The how you put drugs into the body and the food into the body is super important. and we don't
and the
take
timing
Yes.
and the composition, whether it's a carbohydrate, whether it's a sugar, I mean, anything, if it's protein, that's extremely important. Absolutely important.
Okay. Hey, I tell you what. I'm gonna call this one now, because before we get into the food issue,
Oh yeah.
because that's another hour, at least. But this has been fantastic. This has been the most enlightening session. Really, it's quite scary. The interest. I think one of the things about what the circadian work that we have been doing is essentially passive. That we're not asking people to do anything different. We'll just come along with a lighting infrastructure, and everything will be okay. But this seems to be no, that's actually not the case. It's time for everybody to actually pull their own weight and make sure that the life they're leading is the most healthy life. Because hey, go and get some exercise, go and walk about, get on a bike, just go and do stuff where you're actually outside and you're not locked into a building. That is such a radical thing to ask. But it's the thing that, from the sound of it, that's exactly the way we have to, if we have to go, if we want a healthy population.
Yeah.
Well, and just quickly, that last slide is, if people want to learn a bit more, there's a series of videos by Dr. Seholt that I would recommend people listen in on, because this is being driven not by lighting. This is being driven by the medical community, and it's more than just get outside. It's literally, as Roger will go through and say, there was a time where when we went into the hospital, we went out and they would wheel us out into the sunlight, and that's how you were actually healed. Now we keep everybody under artificial lighting in a closed environment with all these flashing lights and things around it. And I think that the medical community is really starting to wake up and start to accept that, hey, we need our patients to be in the best condition they can be to survive, rather than putting them in a hole.
We'll put links to those videos at the end of this video, so that people can at least sort of find them out and just look at those for themselves. But Scott, Deborah, thank you as ever so much for scaring the bejesus out of me, basically. And we'll see what happens next. And I hope the three of us can get back together and we can talk about the next step along this process, because we've only just started it. I know of one designer who is doing a talk on near infrared, and I'm just wondering what the hell he's going to be talking about. Unfortunately, I can't be there, so I need to put a mole inside that presentation just to find out what he's. Well, I could just ring him up and ask him, of course. But everyone, if you're watching
this, like
I
say, anybody who wants, a lot of this is also on our website at niralighting.com. And they want to buy some light bulbs and try it out and give us feedback.
Yeah, and anybody wants to just call me up, I can talk for an hour. So
which we've proven, right, Deborah?
Do I?
Which we've proven, right?
Yeah.
Oh, we have proven that. Yeah.
And we've done very well. And your silent friend is so.
Oh yeah, leaky.
Polite.
I just hope people don't compare me like, wait a minute, who's talking, Deborah or the skeleton?
Yeah, Jim's not looking as good as he used to. No.
No.
Sorry,
he'd be
Jim.
up here at 6'7". His head would be out of the frame. Yeah.
Okay, everyone, thank you very much for your time. I hope if you're still here, then what an hour you've spent. And if you're sort of kind of as sort of shell shocked as I am about the job in hand, because we've now got a job to do, and there's an awful lot of talking that needs to be done, and there's an awful lot of changing of ways that need to be considered. But
thank you very much, John, for all your allowing us to talk.
Pleasure. Deborah, as ever, a pleasure.
Thank you.
See you all again soon.
Yes. There's so much to be done, but the thing that I'd recommend for any design professional out there is it's more than just what you propose on a piece of paper, or you draft, or you put into CAD, or you say and you hand it off to the electrician to install. you have to take the extra effort. I know when Jim and I did the first and only LEED double platinum and well building in Washington, we actually did our own grassroots survey and did seminars for all the employees as to what to do when they got off work to support the lighting that they were going to get during the day. And we gave them individual sessions with us to be able to find out what their reproductive viability was, to be able to say, okay, well, now, since you've been stuck in this cubicle all day, when you go home, you need to do da-da-da-da-da. And, you know, which is different than a 50-year-old man versus a 20-year-old who has, you know, designs to have a baby in the next year or two. And so you have to be almost a paramedical in order to be a really good lighting designer these days. If you really want to make if you really want to make a biological difference, other than just sell, okay, circadian lighting because it comes in a box and has circadian on it. You know,
Yeah.
you have to be more than that.